All right, everybody, at the top of that one, it should say partial fraction decomposition. We're going to go over this, but first I'm going to give you some procedures on how to actually do this. So flip it to the back where there's that blank page. We're going to take just a couple notes. 5 steps that will help you solve all these problems that you're going to do in your homework. So first, number 1, write down proper fractions. Does anyone have an idea what proper fractions are?
The bigger one is not improper and smaller number on the top.
Okay, good. Smaller number, we're going to talk more with, we're working with polynomials, and so we're going to do a smaller degree instead of the number. So that means that the degree in the numerator needs to be smaller than the degree in the denominator. What happens if it's not a proper fraction, like if the degree of the numerator is higher than the
It's a mixed number.
improper fraction? How can we change that to a proper fraction? Factoring helps.
Mixed number.
Also, I don't know if you guys like this, but long division. Long division of polynomials. That will get you a number off the side, and then it'll leave you with the remainder, which is going to be a proper fraction. But we'll go over that a little bit later. Second, we're going to write down, we talked this already, factor. The denominator. And the numerator if you need to. We're going to factor these into 2 different types. First, linear or quadratic. Okay, who knows what's the form of a linear factor? Mx plus b, good. Where you got your m is your slope, your b is your y-intercept. But we're going to actually, because we're going to use b a little bit later, I'm going to change that to do px plus q. That one is going to be linear. And who knows what's the form of a quadratic?
Ax squared plus bx plus c.
Great. So we got ax squared plus bx plus c. So here we are, we've got linear and we've got quadratic. I'm also going to put parentheses around these, because sometimes they may repeat. And the repeating factor is going to happen when you have it raised to a certain power. So we'll do this raised to the nth power, and this raised to the nth. Nth power. It's an nth. Alright, so that's good. First, proper fractions. Second, factoring. Now, third. Here's where we get into the procedure. For linear factors, assign the sum of n partial fractions. Okay, so number 3 has to relate to 2a right here with the linear ones, and those ones are going to look like this. First, you're going to have a over px plus q. That's going to be number 1. And then if needed, if they're repeated, we're going to do a2 over px plus q squared. And then if needed, dot, a sub n Okay, so how does this look? So just for your linear ones, you're going to have these different forms. Your first, an a over px plus q, and if you have it repeated, whatever your n is, you're going to add up as many n's as you need using the same form. You're going to do px plus q squared, then if you had 3, px plus q cubed, and then so on until you reach whatever your n is here.
What's A?
A is just going to be a constant that we're going to figure out, and we're going to go through that a little bit later. So yeah, we don't know A, but we're going to use algebra to figure it out. So fourth, same thing, but just for quadratic factors. Assign M partial fractions, but these ones are going to have a different form than our linear ones. We're going to do bx plus c all over n squared plus general form. Okay, so what do we notice that's different about these quadratic factors rather than these ones?
We're doing them to the nth power.
You're doing to the nth power, good, because that's just how many times it repeats if you have them factored correctly. What do we notice in the numerator? Yeah, you've got a quadratic down here. Up here you've got a linear. Since there's a power of 2 here, you can have a power of 1 here. Down here there's only a power of 1, so you're just going to have constants up top. So everything that's in your partial fractions is going to be 1 less degree in the numerator. So we'll look at that. And then fifth, this is where we use algebra to find A, B, C, etc. And a little side note, equate corresponding coefficients. Yes, go ahead.
On step 4,
Mhm.
you said that the degree of the numerator is 1 less.
Mhm.
So then why don't we square the second one?
Square
Like-
which one?
You have the first term, and then you have the second term. So why is that still the numerator to the first term?
Oh, okay, good question. Well, we're taking care of that with the powers out here. The whole factor term by itself has a degree of 2, even though with this squared, then it would make it
Okay.
4. But we're really just going to talk about the factors, which
So-
is the quadratic one right here.
Will the numerator ever change?
The numerator?
Yeah.
Yes.
So when does it change?
We're going to figure out the numerator with certain examples.
Okay. So, like, does it ever change powers though?
This won't? No.
Okay.
No, not in this case. Okay, so everyone have this written down on the back of their paper? Okay, good. Now we're going to turn over and go to actual 10.5.
He's curious.
everyone see this? Okay, let's start reading at the top here. Partial fraction decomposition. It's the process of breaking down a rational function or fraction into two or more simpler rational fractions. Step number one, who wants to read that for me? Go ahead.
The beginning rational function must be proper, that is, the degree of the numerator must be less than the degree of the denominator.
Good, thank you. So that's what we did for by step number one, make sure that it's a proper fraction. A says, otherwise use long division to get a polynomial and a proper rational function or the remainder fraction. Alright, will someone read number two for me?
The beginning rational function must be in reduced form, otherwise factor numerator and denominator and cancel like factors.
Great, so we talked about that in number two, factoring them, and we're going to get linear and quadratic only in this class. Number three, who will read that for me? Go ahead.
You look at only 4 situations depending only upon the completely factored denominator. Should I read all that?
Please.
Alright. The denominator contains only linear factors, none of which are repeated. The denominator contains only linear factors, one or more of which are repeated. The denominator contains one or more irreducible quadratic factors, none of which are repeated. There may also be linear factors, which may or may not be repeated. The denominator contains one or more irreducible quadratic factors, one or more of which are repeated. There may also be linear factors, which may or may not be repeated.
Wow, that's a mouthful. But all really important, and we're going to go through 4 examples, one of them with each of them. So, and the note says x squared, and then the quantity x minus 3 cubed are linear factors, repeated. The cube makes it repeated 3 times. Then x squared plus 4 is an irreducible quadratic factor. Okay, so let's first start with this one. We have 3x over x squared plus x minus 2. What's our first step? Proper fraction. Is this a proper fraction?
Yes.
Why?
The degree.
Right, the degree of the numerator is 1, the degree of the denominator is 2. So we're good. Let's move on to the next step. What's step number 2?
Factor.
Can we factor the numerator?
No.
Can we factor the denominator?
Yes.
Okay, what's a factor to?
X.
X minus 1 and x plus 2.
Say that again?
X minus 1 and x plus 2.
Good. X minus 1 and x plus 2. So we'll go ahead and write that right beside. And it's still equal. We haven't changed anything yet. Now that it's completely factored, are those linear or are they quadratic? Yeah, are our factors linear or quadratic? They're linear. There's no x squared. Okay, so we're going to use step number 3, linear factors. We're going to assign them, and first off, second, do they repeat? No, they don't repeat. So we're going to have this pretty easy. First we'll do a over one of the factors. We'll do x minus 1. And then we're going to add it to b over the other factor, x plus 2. Everyone following so far? Good. Now, say we want to combine this all into one line, and we want to get 3x on a side by itself. How are we going to do that? Multiply by x minus 1 and x minus 2. Good. So then we would have 3x times x minus 1 and x minus 2, so that would leave it all by itself. And then we would have a, which is already over x minus 1. What happens when you multiply by x minus 1? Cancels, good. So then we would multiply by x plus 2. And then we add it to b, which is right now over x plus 2. When we multiply by x plus 2, that just cancels, turns to 1, and then we would do x minus 1. Okay, there we go. We've got this. Now we can solve. 3x is still going to be on the left, and we're going to have ax plus 2a added to bx